There are many definitions for a system out there, so let's take a few quick examples. Wikipedia tells us that a system is a set of interacting or interdependent components forming an integrated whole. Or according to the Oxford Dictionary, a system is a set of things working together as parts of a mechanism or an interconnecting network. So firstly, a system is a group of parts, that is to say, it is a composite entity being composed of a number of things. In the language of system theory, we call these parts elements. Next, these parts are interconnected and interdependent in some way. That is to say, there is a set of relationships between the elements. Lastly, that through these relations, the elements are arranged in a particular way in order to perform some collective function that defines the system as a whole. So let's take an example of this. A business organization is a type of system. It has a number of parts or elements that are the business departments, such as production, R&D, sales, accounting, and so on. All of these departments are interconnected. They exchange information, resources, personnel, etc. And through this exchange, they are organized to perform some collective function, that is, producing some good or services. There are, of course, many examples of systems, from transportation systems to agricultural systems and healthcare systems. Not everything is a system, though. If we have a group of things that are not interconnected and do not work together, then this is not a system. It is what we call a set, a simple set of elements. An example of a set might be a pile of bricks or a group of people waiting at a bus stop. These compositions have not been designed to work together. Thus, we describe them by simply describing the properties of each element in the set, and that tells us everything we need to know. There is nothing more to a set than the simple sum of their elements. This very important feature to sets helps to make dealing with them relatively simple. Now say we took this pile of bricks and we built a house out of them. We would no longer describe them as simply a set of bricks, because by building our house, we have now added a set of relations, a particular arrangement to them that allows them to function as an interdependent entirety, and this entirety of the house is the system. This helps to illustrate one of the key features to systems and systems thinking, that is, what we call emergence, which we will be discussing in greater depth later on in the course, but for the moment we will note that a system is not a thing. In contrary to the elements within a system that are things like bricks, cars, people, planets, etc., a system is what emerges out of the interaction of these things when they work together as an entirety. This makes systems and systems thinking a little bit more abstract because we can't really touch, grasp, or hold the system. Think of an urban transportation system. We might be able to see a bus or walk on a road, but it is difficult for us to grasp the whole that is the system. Whereas the elements within a system have well-defined boundaries, the system as a whole is a much more open and nebulous thing. Thus, it is not surprising that we often resort to using analytical methods whereby we simply describe the system by describing all of its parts, thus reducing it to a simple set. When we are dealing with sets, we use what is called set theory. Set theory is essentially the foundations of contemporary mathematics and thus, by extension, contemporary science, which both represent the analytical method of reasoning. And not surprisingly, when we're dealing with systems, we need to use systems thinking that is based upon synthesis.